Assalamu alaikum. In this video, we solve some exercises that you have seen in the worksheet 2 and the worksheet 3 of this chapter. In the given of the first application, we have a neutron that interact with a uranium-235 to give strontium and xenon with emission of 12 particles. Also, the mass of each element is provided in the table. In the first equation, we have to specify why this nuclear reaction is provoked. The answer is simple. We say that it is provoked due to the impact of incident neutrons that acts as an external intervention. In the second equation, we have to specify the type of this nuclear reaction. The type is fission, since the heavier nucleus is divided into two light nuclei, Sr and Xe, under the impact of neutron. The third question asks, what is the condition on the incident neutron needed to satisfy this equation? We say that the kinetic energy of the incident neutron should be around 0.025 electron volt. Then we have to determine X by specifying the used law. We apply Soddy's law, then we get A equal to 1 and Z equal to 0, which is correspond to a neutron and 1, 0. In the fifth question, we have to deduce that this nuclear reaction is a chain fission nuclear reaction. We say that since we have 12 emitted neutrons, so each neutron with the suitable condition will stimulate another uranium. For this reason, we say that this reaction is a chain nuclear reaction. In the sixth question, we have to name the method used to reduce the kinetic energy of the emitted neutrons. We say that we can use a moderator which will control the kinetic energy of the neutron. In the seventh question, we have to calculate the mass defect. Then we have to deduce that the energy will be released from this reaction, and then we have to calculate its value. So we apply the rule of the mass defect. We know that mass defect is defined as the difference between the mass of the reactant minus the mass of the product. We substitute the values, and then we get 0.13584 U. But we have to convert this mass into kilogram. So we multiply it by 1.66 times 10 power minus 27 kilogram, and then we get 2.25 times 10 power minus 28 kilogram. It is greater than 0, so this reaction liberates energy. So to calculate this energy, we apply the rule E equal delta mc square. I substitute the values, and then we get 2.029 times 10 power minus 11 joule. In the eighth question, we have to calculate the amount of energy liberated by 1 kilogram of uranium-235. The amount of mass of uranium-235 used in this reaction to liberate 2.029 times 10 power minus 11 joule is 235.04392 U. But we have to convert this U into kilogram. So in 1 kilogram, how much we will get? We will get E. So if we make the calculation, we get E equal to 5 times 10 power 13 joule. Application 2 explain how the generated energy by stars can be produced. The nuclear reaction that takes place is given here. We have two elements of helium-3 combined to each other to give helium-4 plus 2 particles donated by X. Also, we have the mass of each element, and we have C and how to convert it from U into kilogram. In the first question, we have to explain why helium-3 and helium-4 are isotopes. We say that since we have two same elements of same atomic number but different mass number. In the next question, we have to specify the type of this nuclear reaction. We say that it is a fusion since two light helium-3 combine to form a heavier element, helium-4, as shown here in the equation. In the third question, we have to indicate where such kind of reaction are generally takes place. As mentioned in the text or according to your acquired knowledge, such kind of reaction takes place in stars. In the fourth question, we have to give the order of temperature needed to fuse two helium-3 elements. It is approximately equal to 10 power 8 Kelvin. In the fifth question, we have to determine X using a specific law. We apply Soddy's law. We have, in the conservation of mass number, 2 times 3 to give 4 plus 2 times A. Then we solve and we get A equal to 1. In the same way for the atomic number, we have 2 times 2 equal to 2 plus 2 times Z. Then we solve and we get Z equal to 1. So the emitted particle is hydrogen H11. In the last question, we have to show that this reaction releases energy and then we have to calculate its value. We should first calculate the mass defect. It is defined as the difference in masses between reactant and the product of this reaction. We substitute and then we get delta M equal to 0.014875 U. We have to convert it into kilogram. So we multiply it by 1.66 times 10 power minus 27. So we get 2.469 times 10 power minus 29 kilogram. It is greater than 0, so this reaction liberates energy. To calculate this energy, we apply the rule E equal to delta M C square. We substitute the values and we get 2.22 times 10 power minus 12 joule. At the end, I recommend from you to watch this video many times and try to solve these exercises again. Wassalamu alaikum wa rahmatullahi wa barakatuh.